8.4, like I said, no graphing. Hooray. We're working with logarithms more. We're not going back and forth between exponential form and log form like we did yesterday and before spring break. But this time we're just kind of manipulating logs to look whatever way it says. And there's 4 properties that can make this happen. We're really going to use 3 of them today, and the 4th one is the easiest one, so we don't use it very much. So here are your 4 properties. The first one is product. This one, if you see, we're taking log base b of 2 variables multiplied together. You can separate that into 2 different logs with the same base. Okay, see log base b, log base b, and separate the 2 variables m and n. One goes with one log, one goes with the other one, and addition is in between. All right, so here's an example. It was log base 3 of 9x. That's the same thing as log base 3 of 9 plus log base 3 of x. And so you can also go the other way. Like say you started with the addition. If you wanted to combine them and just get a single log, you would say, okay, 9 and x, I'll multiply together. So product property goes back and forth between multiplication and addition. I'd write that on the side so it's easy to recognize. The next one is very similar, but instead of multiplication and addition, it is division and subtraction. So we can go ahead and write that, and then we'll look at it. So it goes back and forth between the 2. It is called the quotient property. All right, so here we have 2 variables, m over n. If you want to separate that into 2 logs, you have log of the numerator minus log of the denominator. Okay, so we can do the opposite too. Like say both these logs have base 1/4. So you have 4 minus 5, so that it end up being log base 1/4 of 4 over 5. Numerator is the first one, the denominator is the second one. Okay, so if you see subtraction or division, you're probably going to work with quotient. The next one is about exponents. Okay, so if you have an exponent attached to whatever you're taking the log of, you can move that exponent to get rid of it, move it to the front of the entire thing. So that p that was the exponent is now the coefficient. And you can go vice versa. Say you start with this x in front, but you don't want anything in front of the log, move it to be the exponent here. So just like it says here. So power property goes back and forth between exponents and coefficients. And a lot of times we'll actually combine this one with one of these. Okay, so sometimes you'll have power property with either product or quotient. Sometimes you can have all of them together. We won't see that a lot today though. The last one is equality, and this one's just kind of common sense. That if you're taking, I'm going to use the example to show you. You're taking log base 8 of 3x minus 4 and log base 8 of 5x plus 2. Well, you can, log base 8 is the same thing on both sides. So basically, you can make that go away and say, well, 3x minus 4 must equal 5x plus 2. So it's equality. When they have a common base, then you can have equality there. But there can't be anything in front of the logs in order to make that happen. All right. So the first examples that you're going to have are, you're just going to state which property is used to get from the left side to the right side of the equation. So how did we get from log base 2 of 8 minus log base 2 of 4 to just log base 2 of 2. What property did we use to get from here to here? Quotient, right? Because you start with subtraction, and then, let's see, 8 divided by 4 would give us 2. So that works. It went from subtraction to division, so that is quotient property. You can just write quotient. Very good. On the next one, how do we get from left side to right side?
Exponent.
There we have exponent and multiplication here and neither here, right? It turned from exponent to coefficient, that 3, and then multiplication to addition. So we have more than one property. Which ones? Power and product. Any questions so far? Yeah. The first 4 problems are like this, where you just state the properties. Okay. The next set of questions, you are going to simplify the logarithms. It says, write each logarithmic expression as a single logarithm. So we want just one log in our answer. So how can we combine these? The operation between them is subtraction. So when we combine them, what will we do between the 20 and the 4? Based on up here, whoa. When it's subtraction, you turn it into a division. So we need 20 divided by 4. And what is 20 divided by 4? 5. So log base 3 of 5 is your answer. And we use the quotient property to make that happen. Okay, the next one, what do we need to do? Before we can combine the 2 logs, we need to get rid of the 3 that's in front. So where can we move it? It'd be x cubed, right? We take this 3 and move it to the exponent. So we'd have log base 2 of x cubed plus log base 2 of y. Now that we have nothing in front of the logs, how do we write them as a single log?
We go from multiplication to addition.
It's already addition, so go to multiplication, yeah. So x cubed times y. And don't forget to always write your base in there, whatever it is. Any questions there? No? Okay, before you combine them, just make sure you get rid of any coefficients in front. All right. The last set of problems, we're going to expand the logarithms as much as we can. Okay, so right now they're all like condensed in one log. We want to separate them out as much as we can. So what can we do to this one to separate the x and the y? What operation goes between them? Subtraction. So log base 5 of x minus log base 5 of y. We don't have any exponents or anything here, so that one's done. Okay, last one. We're trying to expand it as much as possible. When you're expanding, you're going to deal with your exponents last. Okay, so first we need to separate a cubed from b to the 4th. So what operation would go between the 2 logs? Addition is correct. Very good. And now, to keep expanding it, now move your exponents. Where will they go? They're actually each going to go to their own log, but they're just going to become the coefficients. So you'll have 3 log base 7 of a plus 4 log base 7 of b. And there's your answer. So when you're simplifying, condensing them down, you've got to move your coefficients first. And when you're expanding them, moving exponents to coefficients is last. Any questions? All right then. You have like either 11 or 12 problems. You got it. So the back of the notes, this only goes for pre-AP. So if you're regular class, then you don't have to worry about this. But if you're pre-AP, then here we go. So here is a situation where logarithms are used in somebody's real life. Logarithms are used to model sound. Okay? The word sound? Okay, the intensity of sound is a measure of the energy carried by the sound wave. That's that whole long blank. Energy carried by the sound wave. Got a little messy there. That says sound wave. The greater the intensity of a sound, the louder it seems. So loudness and intensity, they're related, but they don't mean the same thing. They don't represent the same thing. This apparent loudness L is measured in decibels. Have y'all heard of decibels before? The unit abbreviation for that is D, not an M, don't put an M there. D capital B, lowercase d capital B, decibel. You can use the formula supposed to say L equals 10 log of I over I naught. When you have a little zero subscript, you say naught. It's like the original is what it means. Okay, so we have that formula where I is the intensity of the sound in watts. Okay, so intensity, its units are watts. Loudness is decibels. It's watts per square meter, actually. W over m squared. Okay, and I naught is the lowest intensity sound that the average human ear can detect. So that's like a set number, I naught. And we have this little graphic over here that I think is kind of cool. So the threshold of hearing is at 0. Okay, so that's the point where we can begin to hear. And then it's like 20 decibels, leaves rustling in the woods. A refrigerator, that like constant hum, is at 40 decibels. Boiling kettle, so that'd be like that whistle, would be 50. Let's see, normal conversation is 60 decibels. An alarm clock is only 20 decibels above a normal conversation, and that is loud, right? Alarm clocks are loud. And just above the alarm clock is the dangerous continuous noise. This loud harms hearing. Ooh, don't get too close to your alarm clock without turning it off. Let's see, motorcycle, 10 meters away is right above that. MP3 headphones at max is above that dangerous continuous noise at this level harms hearing. Yeah, okay, just want to put that out. Okay, let's see, just above that, we got our football stadium, a jet engine at 30 meters away. That's pretty close, but that's pretty loud. Here's where like noise actually hurts your ears. You feel the pain, and then here's the physical damage, like to your ears, be messed up.
It's weird that like the cheering football crowd is like just a little bit above the MP3, but then it's
Yeah.
like a little bit below the jet.
Depends on what football crowd you're in, 'cause ours is like.
I think they mean like a like
Stadium.
stadium. Yeah. Okay. So we are going to use this to figure out this problem. It says a shipping company has started flying cargo planes out of the city airport. Residents in a nearby neighborhood have complained that the cargo planes are too loud. This is like a very possible situation. People are always complaining about loudness. Suppose the shipping company hires you to design a way to reduce the intensity of the sound by half. So intensity needs to be cut in half. By how many decibels? Okay, so remember decibels are loudness. The watts are what went with intensity. How many decibels would the loudness of the sound be decreased? Okay, so they want to know if you cut the intensity in half, how much does that affect the loudness? Remember, they're two different things. Okay, here we go. Let's set up some variables. We'll say that we have two different intensities. Intensity 1 will be our present intensity, so what it is when everyone's complaining. And then intensity 2 will be our reduced intensity, the one we want. L1 will be present loudness, and L2 will be reduced loudness. So what are we hired to do? Like, what do they want to make?
Reduce the sound by half.
Reduce the intensity by half. So our reduced intensity will equal what? Half of the original intensity, I1. Okay, very good. Now, remember, they gave us a formula way up at the top of the paper that tells you how to find loudness. Loudness equals 10, oh, can't see it, 10 log of whatever I we're going for over I naught. So we can make two formulas out of that. We'll have that loudness 1 will equal 10 log of intensity 1 over intensity naught. And loudness 2, the reduced one, will equal 10 log intensity 2 over intensity naught. Okay. Now, the question asked, how many decibels would the loudness of the sound be reduced? So they're like, what's the difference between the first one and the second one? So what we're going to do with that is say, well, what is L1 minus L2, right? If we can figure that out, we have our answer. Let's plug in what we just said L1 and L2 are. Do it? Well, yes. We have up here intensity 1 that we can plug in for intensity 2. So let's do that. We want to put this right there. So I'm going to come back up to the top because I'm running out of room. So L1 minus L2 will equal 10 log intensity 1 over intensity naught minus 10 log 1/2 intensity 1 over intensity naught. So Casey suggested combining them, but that we could probably get somewhere with that. But if we actually try to separate this out, we might do a little better. Hint, hint. Okay, so what is happening between the 1/2 and this intensity 1 over intensity naught? Multiplied. Multiplied. Let's kind of leave this together. Since it's together over here, we'll leave it together here. So how can we separate the 1/2 from that?
Do the little exponent thing.
Well, it's not an exponent. They're being multiplied.
Coefficient.
No.
Add it.
Add it.
Yes.
Add it.
What are you talking
Yes.
about?
Okay, let me write it out. Okay, so L1 minus L2. That's not changing. The first chunk is not changing either. We'll leave it. And then we have a minus, and we're going to leave a bunch of stuff in parentheses here. We're going to make, oh, whoops. Hold on. Before your parentheses, the 10 needs to be up there too. We haven't dealt with the 10 yet. I hear you huffing. Okay, so we're just dealing with the log part. We'll have log of 1/2 plus log of intensity 1 over intensity naught. You with me? So I left the negative 10 just in front, not dealing with that at this moment. But I just wanted to split the 1/2 away from the intensity 1 over intensity naught. So I broke them into 2 logs and there's addition between the 2 logs based on our product property that we learned on the front. Okay, anybody see what's going to happen yet? We're going to distribute the negative 10, so it's going to go in front of both of those. So L1 minus L2 will equal 10 log intensity 1 over intensity naught minus 10 log 1/2 minus 10 log intensity 1 over intensity naught. Anybody see it now?
Not exactly.
Combine like terms.
Combine like terms. What happens when we combine like terms?
They cancel out.
They cancel out. This one cancels with this one. Yay, because one of them is positive 10 and one of them is negative 10. So, L1 minus L2
equals negative 10 log 1/2.
I think you can put that in your calculator. No one has a calculator? Nope, nope. You can, because it's base 10.
3.01.
So we'll say it equals, what, 3.01 decibels, because it's loudness. So reduction in loudness is about 3 decibels. We'll just say that. So in order to get the intensity of the sound cut in half, you only have to reduce it by 3 decibels. So like your job, say you're an, I'm guessing it'd be engineer, is you got to figure out how to make either the planes quieter or have some like sound barrier. Maybe you need to like plant some trees or put up a wall. Yeah, I don't really know how much 3 decibels is, but that would be your goal.
How many colors do we have on our homework?
Of these, I think like 1 or 2, maybe just 1. Okay. Yeah, it's kind of long.
We don't need wrapping.
You do not need drafting paper.